Okay, this is the 2005 Sec 3 Express end of year paper. Okay, the first questions is on chromatography. So 1A, explain why the starting line is drawn using pencil. Now, the question asks you why using pencil. So you have to explain pencil. You should not explain pen. So the keyword is the pencil is made of graphite, which is insoluble in the solvent and which is alcohol. Okay, so you should not explain using pen. I mean, you should not explain it from the pen perspective. I think this time I'm quite lenient. If your explanation using if your explanation from the perspective of pen still makes sense, I think I still give you some marks, but I will not be so lenient next time. Okay, for B is green, not much to explain. Okay, which chromatogram is obtained using the descending method? Explain your choice. So most of you are able to explain this part to identify first of all chromatogram X, and then the solvent front travel a further distance, and I think most of you are able to explain that because it has a greater gravitational pull. Now calculate RF value. RF value should not have a unit, and again the final answer should be 3SF. So for the entire paper, for all the calculation, if any one of them is not in 3SF, 1 mark will be deducted. If you have two answers not in 3SF, only 1 mark will be deducted. Okay, and of course if all your answers are in 3SF, then no marks will be deducted. So maximum only 1 mark will be deducted due to answers not in 3SF. And when you measure the distance traveled by the dye, it must be measured from the center of the spot. Okay, for example over here, you should measure the distance traveled by this blue dye from the starting line to the center of the blue spot. Okay, I think some of you measure the distance from the starting line to the right hand side of the blue spot, or on the left hand side of the blue spot. It should be at the center. So in this case, the distance traveled by this blue dye is 2.5, and by the yellow dye is 5. Okay, calculate the distance. Most of you are able to get this, and then after that draw it on the diagram here. Most of you are able to get it correct. Which method is better to be used in separating the different dyes in the ink? Explain your answer. Of course, descending method. So for this part, any answer that has this meaning, complete separation of dye or faster separation of dye, or the dye will be able to travel faster, hence they are clearer. Okay, all these answer I will accept. Okay, 1 mark for the entire, for 2 key points here. And then for G, this one is quite straightforward, to prevent alcohol from evaporating. Okay, because alcohol has a quite a low boiling point. It is quite volatile. Okay, for question number 2, okay, charges, no problem, the particle's name, as well as the mass. Now the mass for neutron, I would accept anything in between 1 over 2000 to 1 over 1840. And for the charges, I accept both +1 and 1+. And likewise for electron, -1 or 1-. Now explain why the 3 atoms are isotopes of each other. Okay, and this is a 2 mark question. So you should not just give me the definition of isotope, which is atoms of the same element with the same number of protons but different number of neutrons. I expect you to quote the data from the question, which means that you have to tell me for hydrogen, deuterium and tritium, what is the number of protons, which is all 3, and as well as the number of neutrons for all three of them are actually different. So you have to tell me what are they. Okay, what is the relative molecular mass of a molecule of tritium, T2? So there are two of this. So first of all, you have to tell me, I mean the MR would be the number of, MR is basically the mass number, okay, which is the number of proton plus neutron. So in this case, there are 3, and tritium, there are 2 tritium atom, so it will be 3 times 2, which is 6. And then for number 3, this is redox from the redox chapter to calculate the oxidation state of Mn in MnO4 minus. Okay, this one, basically the calculation will be Mn plus 4 times minus 2. Minus 2 is the oxidation state for oxygen, and then equals to minus 1. This minus 1, this charge, is actually the oxidation state for the entire MnO4. And then you solve for Mn, so Mn will be plus 7. And then the second question, is the reaction a redox reaction? Explain clearly in terms of oxidation state. So of course you have to tell me whether it is or it is not a redox reaction. Then after that you have to explain if it is a redox reaction, which is clearly in this case. You have to tell me that which substance is oxidized, why in terms of oxidation state, and which substance is reduced, why in terms of oxidation state. 3 marks. For question 4, this is chemical bonding. Okay, this is quite straightforward, graphite and diamond. So it's trying to draw your knowledge about graphite and diamond, about the structure and bonding in both graphite and diamond. Okay, using the structures above, explain the difference in softness. Now, a lot of you, your explanation to explain the difference in softness, you actually explain it, the difference in terms of boiling point and melting point. So in terms of softness, you don't have to mention things like a lot of energy is needed to break the strong covalent bond. No need to explain this thing. You only need to explain that this one, the layers of atom, when a force is applied, the layers of atom can slide over each other due to the weak intermolecular forces. Okay, so first of all, you have to tell me which substance is soft, which substance is hard, and you don't have to spell out the entire hexagonal boron nitrate. You can just mention once and then give it a short form. And then for this cubic boron nitride, mention once and give it a short form, so that in subsequent explanation you don't have to repeat these complicated names over and over again. So the layers of atoms in HBN are held by weak intermolecular forces. How do you know? Because it is just like graphite. The layers of atom are held by weak intermolecular forces, while it should be the layers of atom, not the layers of molecules. Okay, all these are atoms. This entire thing is a molecule, and likewise for this cubic boron nitride, entire thing is the molecule. And all these atoms, they are held by strong covalent bonds. So when a force is applied, the layers of atom in HBN can slide over each other, just like in the case of graphite. And the atoms in HBN cannot slide. Because why? Because they are held by strong covalent bonds. So 3 marks. And then draw dot and cross. Now a lot of you draw the sharing between the two nitrogen atoms. They share 2 pairs of electrons. They should share only 1 pair. Now for nitrogen, you have to write down the electronic configuration, which is 2,5. 2,5 short of 3 electrons, so it should share 3 pairs of electrons. 1 pair, 2 pair, and 3 pairs. Okay, short of 3 electrons, should share 3 pairs of electrons. So if over here is 2 pairs ready, there'll be 2 pair, 1 pair, there'll be 2 pair, 3, 4. Share 4 pairs of electron. Cannot. Okay, so 2 marks for this. So the 2 marks is 1 mark for the correct number of electrons and 1 mark for the correct sharing of electrons. And likewise for aluminum nitrate, it is a ionic substance, ionic compound. So I have to draw this one, nothing much to explain about it. And how about explain in terms of structure why hexagonal boron nitride and aluminum nitride have very high melting point. So you have to tell me what is the name of their structure and how are the atoms in the structures are being held. So atoms in HBN, atoms are held by strong covalent bonds in the giant molecular structure. So giant molecular structure is the name of the structure. You have to tell me that, and large amount of energy is needed to break the bonds. Now in this case, you don't have to say the layers of atoms are held by weak intermolecular forces, because the layers of atoms have nothing to do with the high melting point. The high melting point is due to the strong covalent bonds being difficult to be broken. And for aluminum nitride, ions, so because it is an ionic compound, so the ions are held by strong electrostatic forces of attraction. And what is the name of the structure? Giant ionic lattice structure, or giant lattice structure. So large amount of energy is needed to overcome the forces, not to break the forces. So take note of this: break the bonds, overcome the forces. So a lot of you make the mistake: overcome the bonds, break the forces, and this is wrong. Okay, for number 5, it is calculation of the empirical formula. You must have the table. If you don't have the table, I think 1 mark is taken off. And some of you make the mistake here. This is oxygen atom, not oxygen molecule. So we have to use AR, divided by 16, not divided by 32. And again, this number here, you should not round it off, the number of number of moles. And then over here, divide by the smallest number. Okay, what is the smallest number here? 0.5053. So a lot of you missed this step. So all these 3 number of mole must be divided by the smallest number of mole, which is 0.5053. Yeah, and then you get the ratio. So show the empirical formula, K2FeO4. So K2Fe1O4. So how are the marks being allocated? 1 mark for all these correct number of moles, these 3 numbers, and then 1 mark for these two rows here. And of course, you must have the table. Now, how about for B? For B, balance the chemical equation. Nothing much to explain here. You just have to try and error. Show by calculation and explain which is the limiting reagent. This question we have practiced a lot in the chemical bond, in the chemical calculation assignment, as well as speed test. Okay, so the first thing is to calculate the number of mole of Fe2O3. Then after that, calculate the number of mole of KOH. So 1 mark here, 1 mark here, and then 1 mark for the explanation. Okay, find the mass of K2FeO4. Now, this K2FeO4 is the product. So the amount of product produced depends on the amount of limiting reactant, which means that in order to calculate the amount of product formed here, you have to look at the amount of limiting reactant, meaning that you only have to look at KOH and K2FeO4. KOH, K2FeO4, look at the mole ratio or the mass ratio can also. Okay, but a lot of you, surprisingly, you actually look at the mole ratio between Fe2O3 and K2FeO4. It should be KOH and K2FeO4. Why? Because KOH is the limiting reactant which you found from here. And again, the answer must be 3SF. Okay. Then for part C, write the half equation that shows the color change. And what would be the color change? It says that a few drops of aqueous K2FeO4 was added to test tube containing potassium iodide. And you know that this potassium iodide it is used to test for oxidizing agent. And the color change, potassium iodide, it is colorless and it will change to brown, which is due to the presence of I2. So I minus here will change to I2. That is why the half equation is I minus I2. And this 2 electron, it loses 2 electron. 2 iodide ion loses 2 electron to form 1 iodine molecule. This plus 2 electron, you can actually put it here minus 2 electron. I'll mark you correct as well. So this 2 electron, it can be plus 2 electron on the right hand side or minus 2 electron on the left hand side. Both are correct. But it's better to write plus 2 electron on the right hand side. So what can you deduce about this? It is an oxidizing agent because it oxidizes I minus to become I2. But you don't have to explain. Now for this question, the following test will carry out on 3 aqueous solution. So over here, this add acidified barium chloride. So this is a test for sulfate ion, which means that this white precipitate must be barium sulfate. Okay, and this substance must have sulfate ion. And then solution C, mix, you get green precipitate E, so it must be iron 2 no, this one must be iron 2 something. This one, so the iron 2 must have come from here. So this substance must be iron 2 sulfate. This green precipitate must be iron 2 hydroxide because this is a test for a cation. So this substance here must either be sodium hydroxide or aqueous ammonia. So this E is iron 2 hydroxide. Okay, iron 2 hydroxide. And this one is iron 2 sulfate. Okay, because iron 2 hydroxide turns brown on standing in air, which means that iron 2 hydroxide will change to iron 3 hydroxide. So this substance, either aqueous sodium hydroxide or aqueous ammonia. Okay, here. Then over here, mix, you get a white PBT soluble in excess of solution C. Now, soluble in excess, it can either be zinc, aluminium, or lead 2. Okay, so this solution B can either have zinc ion, aluminium ion, or lead 2 ion. Now over here, add aqueous sodium hydroxide and aluminum foil, then heat. So this is a test for nitrate ion. And this observation here proves that nitrate ion is present. So this substance is either zinc nitrate, lead 2 nitrate, or aluminum nitrate. We don't know which one. Then add aqueous sodium carbonate. Okay, and then you get a white PPT. So it is something like this. So let's assume this to be zinc nitrate. Let's assume this to be zinc nitrate. So zinc nitrate plus sodium carbonate, you should get a white PPT, and the white PPT should be zinc carbonate because this is not a PPT. This is soluble. So this one is zinc carbonate. Heat strongly, you get solid H. When you heat a carbonate, what do you get? When you heat a carbonate, you should get oxide and carbon dioxide. Now this is something that something extra. Okay, only zinc oxide is yellow when hot, white when cool. So this is a characteristics of zinc oxide. Only zinc oxide behave in this way. Okay, that is why this is something extra. And lead 2 oxide doesn't behave in this way. Aluminium oxide doesn't behave in this way. Only zinc oxide behave in this way, whereby it is yellow when hot, white when cool. So this part actually shows that this is zinc nitrate. Okay, however, if you are able to mention that, so this is actually a zinc carbonate, this is zinc oxide. Now if you mention that, if you answer this to be lead 2 carbonate, I will still mark you correct. Okay, because you may not be aware of this. You may not be aware that this is a signature behavior of zinc oxide. So this one I accept lead 2 carbonate or aluminum carbonate. This one I accept lead 2 oxide and aluminum oxide. So even though if you don't know this is a signature behavior of zinc oxide, you will still get these two correct. You will only lose this one. Okay, this one I only accept zinc nitrate because this is something extra. Okay. Now write a chemical reaction, a chemical equation for any one of the chemical reactions. I accept many reactions. Okay, there are many reactions in this flow chart here, so there are many possible answers. And then for the ionic equation for the formation of white precipitate F, which is a barium sulfate. So this is this one I explained it in class. So this is the ionic equation. Okay, let's go on to section B. Now for section B, this is a database question. You have to familiarize yourself with this kind of question because in O-level definitely at least one or maybe two questions of this magnitude will come up. Okay, describe how the freezing point of water is related to the salt solution concentration. Now, salt solution concentration, whereas salt solution concentration increases, freezing point decreases. You cannot say as freezing point decreases, salt solution concentration decreases. Why? Because salt solution concentration is the independent variable. Freezing point is the dependent variable because the freezing point of the water depends on the salt solution concentration. So this is an independent, this is a dependent. That is why you cannot say as freezing point decreases, salt solution concentration increases, because if you say it in that way, salt solution concentration becomes the dependent variable. It depends on the freezing point. No, it should be the freezing point depends on the salt solution concentration. Okay, use the phase diagram to determine the freezing point of a salt solution that has a concentration of 15% by mass of salt. 15%, so you can actually read it up. 15%. Use your ruler and then move across. It is negative 11 degrees Celsius. So I accept anything in between negative 10.5 to negative 11.5. Use your ruler. Now in one sample of salt solution, now the question state very clearly salt solution, that means it only has salt and water. The concentration was found to be 20% by mass of salt. Draw in the box below to show how the particles are arranged at a temperature of -5 degrees Celsius. It is a salt solution, liquid. So when you draw the kinetic particle diagram for liquid, some particles touch, some don't touch. 20% by mass of salt, which means that water is 80%, which means that the ratio of salt particle to water particle must be roughly about 1:4. 20% to 80%, which means 1:4. So every one salt particle, there should be 4 water particles. Okay, 1:4 roughly. So in this case, there are 3 salt particles. How many water? 1, 2, 3, 4, 5, 6, 7. Okay, 7. Actually, you should have more. It should be if you have 3 salt particles, you should have about 12 water particles. Okay, roughly 1:4. So the answer here is actually should have more water particle. Okay, should have more. Oops, never mind, you get what I mean. Okay, in some parts of Alaska, temperatures may drop to negative 20 degrees Celsius. Name the salt Name the salt that can be used to salt the roads effectively. -20 degrees Celsius. Now let's look at this diagram here. What is effective melt temperature? What is eutectic temperature? The explanation is here. Effective melt temperature is the lowest temperature at which a salt solution is able to lower the freezing point of ice. So if the temperature here is -20, your effective melt temperature should be lower than -20 for the salt to be able to lower the freezing point of the ice. So what is lower than -20 degrees Celsius? There will be calcium chloride. So the answer is calcium chloride. And again, the question say name, and a lot of you wrote CaCl2. Is salt effective in prolonged periods of cold weather? Explain your answer. Now, this question, I think none of you got it correct. Prolonged periods of cold weather, you have to relate. What do you mean by prolonged periods of cold water? Cold weather. That means it's snow continuously for a long time. So as more snow falls on the road and melts, salt solution concentration decreases. When that happens, the freezing point of the mixture will rise, and it will make the salt less effective in lowering the freezing point of the water. Okay, so this is question is quite difficult. It requires you to relate prolonged periods of cold weather to continuous snowing. And because there are more and more snow falling, and as the snow melts, the salt solution concentration will decrease. The salt solution will become more diluted. And when the salt solution concentration lowers, then the freezing point of the mixture will rise. Okay, and then for part E, it's salt preparation. Okay, until no more magnesium carbonate will dissolve. This is to ensure that all the acid has reacted. This one is straight out from the mind map. Filter the mixture to remove the excess. Now, whenever you have to describe filtering the mixture, you have to always good to identify the residue and the filtrate. You should not say to remove the residue. What is the residue? And the residue in this case is excess magnesium carbonate. Okay, about half its volume, that is to saturate the filtrate. Filtrate to cool to allow the crystallization to take place. Okay, all this is straight out from the mind map, from the steps of salt preparation. Nothing special. Okay, for number 8, it is basically FGD plant. Okay, name the process. Now some of you just give combustion, but combust what? Unless if the question say name the type of the reaction that provides the energy. Yes, that's combustion. But this one is name the process. So combustion of what? Combustion of coal, of fossil fuel. Yeah. Explain why oxides of nitrogen. This one is because due to the high temperature of the power plant. All this is basically straight out from the mind map, nothing special. And then the chemical reactions. This one is straight out from the mind map or the textbook. Now for this part, calculate maximum mass. If you don't want to use mass ratio, you can use mole ratio. But remember, when you use a mole ratio, when you calculate the number of mole, you use this formula to calculate, right? This mass must be in gram, which means that you have to convert the tons to gram. 1 ton is 1,000 kilogram. 1 kilogram is 1,000 gram. Okay? When you use this formula, bear in mind that the mass must be in grams. Okay? Anyway, you can use mass ratio for this question. Okay, this one is all quite straightforward. 1 possible disadvantages, anyone. 2 harmful effects of sulfur dioxide on health, straight out from the textbook, from the mind map. Now for number 9, it's badly done. Now the formula of aspirin H plus A minus. This plus and minus basically is to tell you that this is the anion and the cation is hydrogen ion. This is not the chemical formula. The chemical formula should be HA, not H plus A minus. Okay, the chemical formula for aspirin, okay, should be HA, not H plus A minus. Okay, write an equation with state symbol to show the precipitation of aspirin when hydrochloric acid acts on the soluble salt of aspirin. Soluble sodium salt of aspirin. So, which means that the salt must have sodium, and then the negative ion must be from the aspirin, which is A minus. So the chemical formula for the soluble sodium salt of aspirin will be NaA, and then plus HCl. All right. So you get NaCl plus HA. HA is the precipitate. That's why it is solid. The rest are all AQ. Okay, because it say already aspirin is not very soluble, but its sodium salt is. Anyway, they tell you that precipitation of aspirin. Now, what does the low solubility of aspirin tells you about the strength of an acid? Okay, of course, it is a weak acid. Most of you got this, but you didn't explain why is it a weak acid, which means that produce very few hydrogen ions due to partial dissociation. So a lot of you missing this part. Either produce very few hydrogen ion, miss out, or miss out partial dissociation. Okay, when a person takes a soluble sodium salt of aspirin, the precipitation only occurs in the stomach. So again, it's trying to explain what is in the stomach. And the stomach has hydrochloric acid. All of you know this. And the hydrochloric acid from here, it causes the precipitation of aspirin. See, this part is related to this. You have to mention what is in the stomach, which is hydrochloric acid. Okay, antioxidant. This one, hydrogen atoms. H8 become H6. Suggests how ascorbic acid is able to act as an antioxidant. Antioxidant means that prevent food from being oxidized. That means it must be able to do something to the oxygen in the air. So the hydrogen atom from the ascorbic acid react with oxygen in the air to form water. Okay, so these two hydrogen atom here, lost two hydrogen atom, right? So the two hydrogen atom actually react or combine with the water with the oxygen in the air to form water, like in this chemical reaction. H2 from the ascorbic acid combine with the oxygen to form H2O. Then of course you can balance it. You put a 2 here, and then you put a 2 here. And finally, for the last part, calculation to find out the percentage of vitamin C in each tablet. So there is 1 mark for the number of mole of the iodine. Then after that, the mass of vitamin C, 24.64 milligram, and then the percentage of vitamin C in each tablet, it should be upon 50 gram, because each tablet is the mass of each tablet is 50 milligram, so it should be 24.64 from here divided by 50 times 100%, and again it must be in 3SF. Okay, so 1 mark here, 1 mark here, 1 mark here. And for this one, these two are actually 1 mark, these two. Okay, must be your conclusion here must be supported by this 24.64. Okay, that's the end of the paper.